All right, thank you guys. I'm at NVIDIA. We've got Aviz Networks. We're going to talk to you about a SONiC-based open packet broker, and it's for both 5G and enterprise kind of monitoring. My name is David Iles, and as mentioned, I'm at NVIDIA. I'm responsible for AI networking solutions and ecosystem, and I'm joined by Chid, who is the CTO over at Aviz Networks. And so we're going to tag team this a little bit. We go to the next slide here. First, just a little bit of a, hopefully everybody here knows what a packet broker is, but we're going to get into the details of it. But the question comes in, so why SONiC, right? Why would you pick SONiC for this? And you know, honestly, you look at Linux Foundation, and there's a bunch of different options for open networking, but none of them have really the mass community support and the architecture that matches SONiC. And so for something like this, SONiC brings a couple of very good things to play architecturally. Because of the way it works with SI and the basic modularity, it is really conducive to having a software vendor come along and create innovation that takes advantage of all of that architecture. At the same time, allowing a hardware vendor like ourselves being able to expose our innovations. And so just as architecture in general is going to be put head and shoulders over some of the other operating system choices. The other thing, though, if you look at who's a likely consumer of a packet broker, a lot of these people, especially in the 5G market, but even in the enterprise, are people that use SONiC on their production network. And so wouldn't it be great to be able to take the same operating system, maybe the same switches, and use them for their production network as well as this kind of tap aggregation, packet brokering network, that ghost network that goes alongside the regular network. And finally, there's a lot of people that are very interested in SONiC, but they're not ready to kind of go full bore and put their production network into using SONiC. And a good way to kind of put their toe in the water and like get some experience using SONiC is in this packet brokering network, where you know it's important, but you know they're not going to lose their job if it goes offline for a couple minutes. And so at NVIDIA, we're huge supporters of SONiC. We've been supporting it and helped develop a lot of the SI stuff. And SONiC, we're constantly contributing more and been doing it since 2015. We are big proponents of most open source kind of solutions, but when it comes to SONiC, we've seen a few different people take different approaches that are less open, where they might create a private build, a proprietary version of an operating system. And our approach, in fact, you know, somebody asked me just today, so when are you guys going to change your approach and start offering a private build? So we have no plans to. We think that the approach that we have is a superior approach, where you get the fully open source software that you should have complete portability from one hardware vendor to another. And a lot of people who ran into hardware issues in COVID where they couldn't get a source, SONiC's amazing for that. Anyway, so I'm going to pass this over to Chid as we start looking at some of the requirements for an open packet broker. So.
All right. Thank you, David. Yep. The room is not full. We tried to pull in the AI element by co-presenting with NVIDIA, but it's not good enough, looks like. OK, next time. All right. Thank you, David. So I think David introduced me. My name is Chid, and we are from Aviz, true neutral vendor to enable community SONiC and taking into the enterprise and telco deployments, right? So yes, SONiC, we have been in the community for 4+ years, and we have seen SONiC how it is in terms of the feature richness, scalability, robustness, and everything. But one of the things is when you go to an enterprise or telco, there's a challenge. There's still a pushback saying that, is it ready, right? So that's where we are here, and we have two approaches, right? One is starting with day -1, wherein which we enable the customer trying to get it started from day -1, which Vishal, see, you talked about it yesterday about our software stack. And another approach is have the customer have the experience in a non-disruptive network. Right? And the choice there is a monitoring network. of course, we are not a packet brokering company, right? So our goal is to enable SONiC. That's the whole idea here, right? So packet broker is a very unique, simple configure and forget configuration in the enterprises and telco, right? So we wanted to try that out to make sure that the customers have the confidence that even though the packet broker doesn't need a lot of features, but at least the infrastructure in terms of the base Debian packages and the management and everything is ready, and they feel comfortable moving to SONiC into the production, right? Starting with that, okay, that was our approach to get into this network packet broker, right? So we started looking at the requirements. We classified this network packet broker into 3 different requirements, right? One is a simple data center monitoring and some kind of storage, optimization and security, and finally telco. So the complexity goes from top to bottom, because when you look at data center monitoring, a simple AR span will do, or a tab connected to simple filtering and forwarding will do. A lot of fixed function ASIC Studio does the job, right? You just have to enable, program a bunch of ACLs, it will get it done. But then the complexity goes more when it goes into the enterprise security, because a lot of information is in the packet which you don't want to see. And today, some of these are done at the server level, running complex applications, expensive, not fast enough, right? And the last one is on the 5G, which is very much complex because you don't even know. We are looking at GPRS tunneling protocol. The encoding is there. Every service provider has their own encoding. SBI from Ericsson and N11 from Ericsson, these are all 2 different. And 5G has its own standard, and it's very difficult to calculate. So these were the requirements. First, we start. So, I'm sorry. Oh, yeah. So looking at its requirements, there are 2 elements to it, right? When you want to build it, yeah, you can build a software appliance and run it on a server and get it done. But then you need to see the performance, how its performance is the hardware, right? That's other challenges. We have accelerators like DPDK, ABPF, a lot of systems there, but still it doesn't get to the physical switch performance, right? And so one is the software element. We looked at SONiC, and we saw that it is a perfect platform to build it. First of all, a lot of infrastructure, the base infrastructure exists in SONiC, and it is very stable, right? And you don't have to reinvent a lot. You can just live with it and probably enhance it. Minor enhancements will do the job. Second thing is you can do a rapid development by building your own service very fast. And prior to this sessions, there were sessions from Alibaba and others. They have built their own microservice to do certain functions, which proves that you can do a rapid development on your own on community SONiC, right? The last one is the most powerful thing, SI, because this has changed the way how network operating systems can be ported on new merchant silicons and everything, right? And the second part of the element is the ASIC capability, because if you now go talk to customers, like 15 years back, customers doesn't know the architecture of ASIC. Now they know in and out of what an ASIC can do, what it cannot do, right? And they have the direct connectivity to the architecture stream of the ASIC. They know what it can do, right? Say, ask the questions. We know that Spectrum can do it, right? So why can you not enable us in that? So that really helped, and SONiC provides a platform to enable it, right? And of course, SI does a certain job, and then we have to take it further. That's where we did, okay? And one of the cool element of it is SONiC SI is we just did the porting on Spectrum 1, and within 2 weeks, we had enabled it on all the platforms, 1 to 400 gig, Spectrum 1 to 3. And we are right now doing it on Spectrum 4, by the way. Right? So that is the thing. It is not just about, okay, you have to do a 3 months, 4 months of porting and enabling it. It is not the case. Yes, of course, the use case is different. Then you have to write a new parser and everything. But for these use cases, it is very easy to do. So taking that into context, how we built it, right? This is our open packet broker architecture, how we did it. We leveraged as much as from the SONiC layer from the infrastructure services. For the management, we used the SNMPs, microservice running, topology discovery, LLDP, all these management services took asset SONiC. And for the NOS functions, which are the bare minimum NOS functions which are required for the packet broker, like link aggregation or VLAN provisioning, we leverage the existing infrastructure. And the good part about it is SONiC provides a nice NOS infra. You don't have to do from Netlink to Redis DB. You get everything. You don't have to worry about, okay, should I write my own RPC or should I write to do my own communication protocol to do it? No, you don't need to do any of those things. All we had to do was build our own microservice which can program the hardware using the SI, and then in order to enable the advanced function of the ASICs, we need to write a smaller element which goes along with the SYNC-D, right? And by the way, this one, we co-developed with the customer. It is not like we developed in our lab and went to the customer and then just try it out. We co-developed because some of these packets, 5G packets, they are not shareable, right? They won't share, customers won't share. And that is the true benefit of doing on SONiC, because you sit in the customer lab and you do it and see what is happening in the network and co-develop it. And then finally get it deployed. With 1 year of continuous effort, we were able to successfully deploy at one of our major telco, and this is how they have deployed it, right? So typically, if you look at it, where packet brokers come into the play in the telco market is between the signaling gateway and the packet gateway, because that's where they try to find out the subscriber information, right? Because and one of the key elements they use is the tunnel endpoint, right? Because that will be unique, even though you move the cells across towers, right? The tunnel endpoint is the key. So based on the tunnel endpoint, they determine where this packet should be sent for analytics or for security purposes or monitoring. That is the fundamental thing. So with this, the capability what Spectrum provides, we were able to do it at wire speed. I'm saying wire speed, and I say wire speed is 400 gig. Not right. So what it does for these customers is that they don't have to they can filter it out before it reaches the analytics tool, right? Number one thing. Second thing is they can do effective load balancing of this traffic into the right analytics tool instead of, say, for example, if you are going to track a particular IMSI or a subscriber information, they don't have to, okay, is this coming to the same tool? It is all taken care by the ASIC. It's with the load balancing does the job. It is similar to the symmetric load balancing of what we do in data center, right? SIP-DIP reaches the same server, right? The same concept, but it is a little bit advanced because the information is encapsulated inside the packet. Right. This is on the telco use case. And of course, for the management and functions, they pretty much everything was available. We didn't have to do anything. We had to enhance a little bit of on the management side because the telco side is a very much SNMP subscriber, and they leverage Zabbix, open source tool, and we have to just do a little bit enhancements on those things and move forward. This is another customer, which is an enterprise who are purely looking at the security side of things, which is they wanted, the use case is slightly different here because they wanted to see what are the traffic coming to the firewall and decide upon, and they decide whether they will decrypt the packet and then decide whether to forward the packet back to the internet or not, right? So they use it at two places here. One is they want to monitor the unencrypted packets and also do a depacket inspection on that, number one. Second thing is also the encrypted packet sent to the tools, what is happening. So what it enables is this. At the end of this is the firewalls will clearly tell and say that what to allow and what to pass. But the advantage of packet broker here is, since you are monitoring at the tap level, it's before it enters the firewall, you can set with the policies of the border router itself, wherein which you can decide these are the packets flows which shouldn't be allowed, and that can be prevented, and the firewall can be limited from overloading with a lot of packets coming in. I'm sorry, how many minutes? Okay, so call to action. We have deployed this, so it is ready. SONiC is ready, and we started with 2019-11. This project, and now we are running on 2022-11, because as the new ASIC comes, one of the things is we have to catch up with the SDK and adding new features, new parsing capabilities, which always comes with the SDK, thanks to NVIDIA, because we were able to work closely with them, enhancing their SI and also working with the actual architecture team to get it done, right? So second thing is we would now want to enhance SI to expose these capabilities of these ASICs, right? That is the fundamental thing, right? It is not a fixed function game anymore on SONiC. It is not about just data center. It's beyond that. We are also working with another customer to provide an end-to-end, because their use case is, okay, SONiC is good, open source, but we want to have an end-to-end solution for the whole packet analysis and everything. And we are now enabling the whole end-to-end solutions with open source. There is a paper published yesterday from our side. You can download it. And that is one of the deployments which we are doing. And yeah, you can experience the Open Packet Broker, the end-to-end solution in our one center, which has it has a live switch, NVIDIA Spectrum 4700 running Open Packet Broker. Thank you.
Any questions? Go ahead.
Good talk here, but I look at the picture you're sharing on the 5G telco case, and then you've been using the GPRS. To me, it's a lot more like the 4G, even 3G part. And then for that picture, and then you have your OPB between two GPRS devices. But we are talking about the 5G case. Actually, there are no that case. And then you have only the GTP tunnel between your GNOB and the UPF. That actually is on the left side of your picture.
Yes, but this
So
is a
are you
picture.
really
Yeah,
confused?
yes, absolutely. So this is a picture which we started deploying, right? And this is a picture which I can share from the customer side.
Okay, but in 5G case, where are you going to put your OPB?
The 5G case, it will go a little bit before, as you said, before the SGW, signaling gateway.
You mean the UPF, right?
Yes,
But there are only one UPF.
there are only
But
one.
you can put more than one, but normally there are only one. And then the GTP tunnel is between GNOB and the UPF. So where are you going to put your OPB? Really
No, it is not about the switch, putting the switch there. It is that the tap goes in between the UPF and the thing, and it is tapped to the switch.
There are only one UPF, not between UPF.
No. Okay, we are not putting, okay.
Confused, but anyway, thanks.
Sure, I can talk to you on that. Thank you.
Any more questions? No? All right. Thank you.